Hey everybody, welcome back to Paleotechnica. Today we're going to be starting a new project, and this one is going to involve the cameras watching this place. I really love the UniFi cameras, but they have a problem. If you don't have your phone or laptop on you, it's really hard to see what's going on outside. UniFi does sell their own live view displays, but they're about $1,000, which is pretty pricey, and they're often out of stock, which is really tough if you're trying to build your system right now. This is where we want to mount the screen, right by the front door. Something that's always on, showing all the live views from the cameras, maybe weather or a couple of other helpful applets. The plan is to make it simple. A self-contained display, no charging, no wiring, just boots straight into the camera view, no nonsense. This is the screen that I ordered off AliExpress. It's a reasonably cheap screen. I guess it's about 10 inches, I think. I forget exactly how big it was. Let's crack it open though and see what's inside. Ordered this a couple of months ago. Been planning on doing this project for a while. Comes with some spacers. I guess this is mounting hardware for maybe the Raspberry Pi. Got some various connectors here. This is probably for the touch screen. I think it uses I2C, and that's how you connect that up. Now in here, this is the actual screen itself. So, oh, actually, sorry, this is the, this is the 10-inch screen from WaveShare. Very well packed, actually. I'm very happy with how this comes. Just pull it out of this. Yeah, a little bit easier if we just get rid of the box there. So this is the 10-inch screen. We have what looks like flex connectors. Looks like the this goes in here. This is probably the I2C connector. We have 4 mounting posts, which I assume are where the Raspberry Pi fits. What's interesting are these 4 pins here, which actually look like, if I'm not mistaken, these are the same 4 pins that the Raspberry Pi POE Hat uses. I'll have to double check that, but it's entirely possible that powering this board itself may directly power the Raspberry Pi. The screen itself is seems pretty nice. Looks like a good quality panel, at least. We'll have to see once the plastic comes off how glossy it is. And the final thing that is in the box are all the flat flex connectors that we need. So we have 1, 2, 3. I'm not entirely sure what each connector is for. Obviously, that says DSI Display. This one is unlabeled. Let's see if we can figure this out. All right. So we have a bare Raspberry Pi here. This one actually looks, I think this one actually has the POE hat already. So I might, because this board I think is going to provide power, and actually you can see, if we look at the bottom here, you can see these 4 pins here match up with this. So these are pogo pins. These pogo pins should mount with the Raspberry Pi's POE hat connector right there. I will probably end up using a different Pi than this one. Since this already has a POE hat, there's no point in using it in this case, because I prefer to power this externally and then have this thing power the Raspberry Pi. I'll have to see, because it's not entirely clear how this is supposed to be used. And there might have been some instructions in here. When I opened it the first time, just to make sure everything was in there, I might have lost them. I'll have to double check. But it should be reasonably easy to figure out. Just as a bit of an interesting aside, I have an older model Pi here. I think this might be a Pi 3. And if you take a look in the bottom, you'll notice it doesn't have the right pins that match up with this. The PoE connector, I think, came with the Raspberry Pi 4. So most likely I'm going to have to dig up a Pi 4 that I have that will fit with this. In the meantime, though, we can just, this one's going to be a little bit easier, just to take a look and see what the camera. Okay, interesting. I have a feeling they provided all these different cables because different Raspberry Pis have different Pi camera connectors. And if you look and see, this one has a fairly wide camera connector. It's, yeah, this one's about 2 centimeters wide. if you look at this one here, the DSI display has a 2 centimeter wide connector roughly, but the Pi side, this one actually says our Pi board, is about maybe 1.5 centimeters, significantly smaller than this. Let's actually take a look. Now this one, it does have the Pi hat on it, so it's a little more challenging to see the size of the connector. So now that I'm looking at this, clearly this Pi and this Pi, so this is the Raspberry Pi 3, this is the Raspberry Pi 4. This Pi 4 appears to have the same full-size camera connector. So I'm really wondering if the idea behind one of these is that this might be for the Raspberry Pi Zero or one of the smaller versions of it. I'm not entirely sure. So it looks to me like we're going to be using this size of flat flex connector. I guess this longer, I guess this is just this longer version is just if you have very complicated mounting requirements. I saw earlier there's a ground and 5-volt here. There is a USB-C here. In theory, if I power this from PoE, so if I get a PoE adapter, the PoE adapter can output 5 volts, power this thing, then I think I can get 5 volts out of this, which we can then directly power the Pi. So the Pis can be directly powered with 5 volts. You have to be very careful because it bypasses a lot of the regulation, but you can power them directly. And in theory, I should be able to power this board, which can then power the Pi. Or I can power the Pi directly, and then the Pi can directly power this board. One of the two should work. One of the questions you might have is, what's the point of using a DSI screen? Like the Pi has HDMI, so why don't we just use HDMI? I think that these DSI boards, my understanding is that the HDMI is a fairly complicated protocol. It has support for multiple resolutions. It's significantly higher overhead. If I understand it correctly, the DSI standard came from mobile phones. So mobile phones didn't want to use an internal HDMI connection because from a power perspective, it's a lot more wasteful than having a much simpler signaling system. I'm going to put on screen what the DSI connector looks like versus what the HDMI connector looks like. It's a significantly simpler system. And the idea is that in a mobile phone, you're not going to be hot plugging the internal display over and over. You have a display, you know exactly what your display is, and you talk to it directly. One of the disadvantages, obviously, of these DSI screens is that they are proprietary. Each of these screens requires its own kernel driver because they have all this proprietary setup code required to get it working, and it's not a very generic system like HDMI is. You have to configure it specifically to work for your system. A driver is actually specific to, like, for example, the Raspberry Pi itself. A driver that might work on a Raspberry Pi isn't going to work on a different ARM system. It requires coordination back and forth between the DSI connector here and the DSI connector on the screen, and so you end up with this combinatorial explosion of drivers required. It it works great if you're building a little self-contained system. You don't have to worry about supporting multiple devices, but it's a much more limited standard, and you're trading off power efficiency for implementation complexity, I suppose. So what we I guess what we would like to do here, first thing we need to do is just try and boot this thing up with one of these two Raspberry Pis. I'm not sure exactly which of these two Pis I'm going to be using in the end. I might end up actually using the older Raspberry Pi 3, but to be honest, I don't know exactly how much processing power it's going to take to decode 4 simultaneous streams. The Raspberry Pi does have a GPU on board. The GPU is capable of decoding H.264. I'm not sure if it's possible if it can decode 4 simultaneous. I'd like to have 4 simultaneous streams at least on screen. I'd like to have them running real time and hopefully around 30 FPS. We'll see if this has enough power. If this doesn't have enough power, then we'll go for a 4. I might have another Raspberry Pi 4 that's kicking around here somewhere. I end up collecting these things. if it comes down to it, I can always just use this one. This one could work just fine if I have to. So what we should do is let's try and boot this thing up using one of these Pis. Just see if we can get it to turn on, see if we can get it to recognize anything, and at least show that this is even remotely feasible. So most likely, actually, I noticed I misspoke earlier. This is the Pi camera interface, and this is the Pi display interface. As far as I understand, they actually both do use the same protocol. I think they're both DSI, but it's just important to remember that this connector here is for the display, and this is for the camera, and they are pretty well labeled in small type there. And I think that's why they provide this very small flat flex connector, because then you can just plug it in here and plug it in here. But between the two of these, I should be able to figure out some orientation that works for this Pi. It took a little while to get this Pi set up, but I think I know what I'm doing now. I need to upgrade the Raspberry Pi operating system on this. Okay, this is going to take a minute here. We just have to dist upgrade. So one of the things about these DSI screens is that the drivers are proprietary, but apparently someone at Raspberry Pi took the time to reverse engineer the WaveShare devices and build basically a module for it that anyone can install. So I think what I need to do is get the latest kernel, which I think should be included in this dist upgrade. And then once I have the latest kernel, I should be able to set up a device tree at boot, which will hopefully allow me to get this screen up and running. This Pi has not been upgraded for quite some time, probably a year or so. It's going to have to install quite a few packages. If this starts taking too long, I might just bite the bullet and flash an entirely new Raspberry Pi OS on this thing. But we'll see. I'll see if I can get this updated without having to reinstall the entire thing. Quite a long process. It probably doesn't help that this Pi is a little bit underpowered. Okay, I think this is going to take some time, so I'm going to come back in a little while, let this go, and hopefully we have a freshly upgraded Raspberry Pi installation that will support this display here. All right, see you in a bit. Okay, so we have successfully rebooted this Pi with the new operating system. Now it's time to figure out how to load the appropriate drivers. So my understanding is that I need to enable an overlay for, so basically a device tree overlay, which should allow this screen to function. We can do it by editing the config.txt. There should be a section in, here we go. So we have DT overlay sections. Okay, so we do need this VC4 KMS v3D. And it looks like we also need to add in DT overlay equals. I'm just going to paste this. And it should be 10 1-inch, I think. According to the forum posts, this driver has apparently been in the Raspberry Pi kernel since 2023. I guess what happened is someone from Raspberry Pi reverse engineered this driver and took whatever was necessary from it to add official support in the kernel. I briefly looked into how this driver was implemented, and it was basically a bunch of raw configuration values that were just not documented whatsoever. Just it was writing a bunch of data to the I2C port, which was then initializing this display as appropriate, and whatever that happened to be. I don't know exactly what those values were, but I'm glad that someone officially reverse engineered this. So we just have to double check, because this, as I said before, each of these screens does require a very specific configuration. And I'm pretty sure that this is they have a 10-1 panel configuration, which I should be able to pick out of this. So there is a panel WaveShare DSI driver inside of the Raspberry Pi kernel. Okay, so there's a WaveShare 10.1-inch panel. Now the question is, what format is it expecting for this data? I don't know exactly. The documentation is not that great here. I'm going to have to figure out exactly what the right string is to provide. What I'm a little nervous about is if I do get this string wrong, will this thing fail to boot? Now, I will say it is much easier to configure an HDMI display because all of this is handled by the HDMI standard itself. In theory, this should be enough to enable the overlay for this screen. Now what I have to do is basically connect this screen. I'm going to have to power this thing down. We can safely change this wiring. One of these challenges here is that for me to hook up this Raspberry Pi, I'm going to need to connect it in a way that I can see the screen, but also manage these connections. And because this is not yet fully configured, I do have an HDMI cable that I need temporarily until I manage to figure out how to get this working. I'm thinking I can use this longer DSI connector, which I think should allow me to reach the Raspberry Pi. I should be able to power the screen. I should be able to reach this over to the Raspberry Pi. It's going to be a little bit awkward, but let's give it a shot. So first thing I'm just going to do is pull the power on this so I safely shut it down. Okay. Now, one of the things I am not totally sure of is what side of the flat flex cable should be up. So let's see. So I believe that it goes in this way. Okay. This is my first time using one of these DSI connectors on a Pi. I've had Pis for many years, but I've never had a chance to try this interface out. So the screen itself has its own FFC. If we look inside, you can see it's very tough to see, but yeah, so this is the correct orientation for this connector. Let's try to get this one in. Okay, then we can clamp that down. Okay, that's seated. Okay, so now we have a rough idea of how much room we have to work with here. Now, I'm not sure if this turns on immediately once I power it. Let's see. Okay. All right, well, let's see. Here it goes. Okay, that's powered. Is there any sign of life? No sign of life from the display, but that could be expected. Okay, next what we'll do, let's try to power the Pi up. I'm not going to hook any other pieces to it. Well, let's just see what happens. Let's give it some power. Let's see if this comes to life. I don't think so. But I'm also not sure if the Pi is booting. Because I don't have the HDMI hooked up, it's unclear if it's even made it past the initial boot up sequence. Okay, I'm going to unplug the Pi, then I'm going to unplug the screen. I'm glad that they send this longer cable because honestly, this would be pretty much impossible to manage if I was trying to do this with the shorter cable. Now, one of the things I did discover is that I was incorrect about these pogo pins are actually not for PoE. This is a very clever design. These pogo pins actually connect to the GPIO header, basically the 5-volt and ground line. So what you should be able to do is if you screw this down, those pogo pins will make perfect contact and this thing will power the Pi. So maybe what I'm going to do here, I'm actually going to do this the other way around. So if we put this in here, again, remembering correct orientation, there we go. That's nice and secure. Also make use of one of these. There's some sort of plastic coating on there. Okay. Yeah, so this standoff will make life a little easier. Now this goes directly in. And the great thing is because the cable is so short, you know that there's no twists. You know the exact orientation. So we know that this is the correct way for it to go in. Okay, so that's in. And we push down. And should be able to lock this in place. 1 and 2. Okay, that's locked in place. Good measure. We'll do a second one over here. Let's see if this is enough to bring it up. Okay, so we don't need to power the Raspberry Pi. We only need to power the screen. Let's see now if we get any sign of life. Aha, okay, so screen is on. The screen is powering the Pi. That's great. Now, I guess that could be a problem. I suppose that there might not be enough power for the Pi and the screen. You know what? I'm going to use a higher power adapter here. I'll pull this. I couldn't find any great options for powering this thing, but this is actually the splitter that I was planning on using for this project. So I'm going to bring this in a little bit earlier just to see if we can get something working. This is a really nice splitter because you give it a gigabit connection. It extracts a 5-volt USB-C connection. It supports up to 4 amps, so it's a very high-powered adapter. And then it gives you a network connection for whatever device you're trying to power. But I know that this is sufficient to power both the screen and the Pi. So let's just try to power these up and see. Hopefully we get a better result. Let's see if we have full power for both devices now. Now, of course, the great thing is that I can use a single cable to connect to the Pi. And I should be able to get both connected. Actually, hold on. I have to secure this Pi better. This is making me a little nervous. Okay. I don't know why they protected these standoffs with this, feels like almost like capped on tape, but it's very inconvenient. It's very hard to take off. I suppose this tape insulates the board if you don't happen to be using a Raspberry Pi. These are probably grounded. Let's secure this down with 4 posts. I'm going to use these longer posts here because if I have to take this apart, these are just so much more convenient. They're a lot easier for me to just take off. They take very little time. And I can torque them by hand very easily. Okay, so we now have that in place. We have it secured down. Okay. This is in much better shape. So in theory, I actually can place this upside down. So let's get the network connection working. And let's power the screen. Okay. All right. Now we have power. Let's see if we can get anything to show up. I'm not sure what's going on, but apparently the light that I'm seeing, the blinking light that I see here should turn solid. Well, the Pi is clearly alive, but the actual display is just blinking and it's not clear why. After a ton of searching and trying to understand what was going on, I think I know what the problem was. I had an old version of Raspberry Pi OS, which is based off Debian 11. The most recent version of Raspberry Pi OS is based off Debian 12. I thought that doing that dist upgrade would get me that latest version, but I don't think it did. It left me on a weird hybrid state. Maybe it was the fully upgraded version of the previous version of Raspberry Pi OS. So what I ended up doing is just reflashing the drive completely. I should have just grab the latest version. So I'm hoping now that when we boot this thing up, we actually do get the full experience here. it is reset, so I'm going to have to reconfigure it, but let's start by just getting this connected here, and we'll give it PoE here as well. Okay, so this is in theory going, it should boot. It's going to boot Raspberry Pi OS, and actually I'm going to use HDMI just for now, just to make sure that we at least get a working system. All right, so it is live. I threw away the old configuration changes when this thing rebooted. Let's see if this boots properly. Okay, so we're back to the Raspberry Pi desktop. Can I SSH in? SSH. See if it's coming up yet. Well, this might take a moment. Should be up now. Aha, okay. First of all, I need to clear out the old host key. There we go. All right, let's try that again. Okay. All right, we're in. Let's, so now we're going to edit the boot config. Oh, okay. Apparently this has moved. All right. Boot firmware config. Okay, so this, we need this VC4 KMS V3D. Okay, so in theory, I need this. As part of the experimentation, I did move it to I2C1, so let's just see if that's necessary. I have to enable the ARM I2C. Okay, here we go. So we want I2C ARM. Okay, let's try rebooting with these options to start. That should give us I2C, and hopefully that gives us a working screen. Okay, is there, oh, okay, hold on. So the light went solid on the screen. Oh, okay, now it's working. There we go. So now we have, I don't know if you can see this, but we have this screen working. Okay, so let's just make sure we have I2C working here. Okay, this is a very good sign. So that was it. I was just using an older version of Raspberry Pi OS that it didn't have the drivers, and I guess you just have no idea if the drivers are working or not. They must silently fail to load. There were no errors in the logs. I don't understand why it continued to boot. Okay, so let's just run I2C detect, which should now, aha, okay. So we do have what appears to be devices there. And actually, let's see if I can do, this might be a little awkward. You know what? I'm going to disconnect the HDMI. We don't need that because we should have a working screen here. Okay. Now let's flip this guy over and you can see, but is there any sort of touch? Okay, there doesn't seem to be touch. Oh, wait, no, no, there is touch working. It's a little glitchy, but touch is sort of working. I wonder if I've misconfigured something. The other thing it could be, these PoE adapters are actually pretty noisy. I wonder if it's not liking the PoE. Maybe that PoE adapter is not going to work with this. I'm not sure. I previously had some other problems with these PoE adapters. They were causing interference on the HDMI output to the point where I couldn't get the HDMI output to even work with basically I have a remote KVM here in my office, and as if I was using one of these things, it would completely fail to sync with the HDMI because I guess this thing is just so noisy. It doesn't seem to be causing a problem here. Like, I'm getting some touch input. I'll have to see. Maybe there's something I'm missing here, but this is a great sign. So clearly it's working. The device is showing up on I2C. Actually, there is another, I'm going to try something slightly different. I2C VC. Let's see if this is actually a better experience. Okay, so we get a Raspberry Pi splash screen. That's cool. It'd be really nice to replace this though with my own splash screen. We'll have to look into this in the next episode of this this project. The screen quality is really nice though. I'm very happy with how this looks. Once this boots into the desktop. Okay, so here's, the touch seems to be working as you'd expect, mostly as you'd expect. I can at least move the mouse, and clicking sort of works there. There you go. I think we can rotate the screen most likely. I'm not sure if I can get it to. We go preferences and screen configuration. Nope, is that not? Okay, so here's this screen. Can we, if I tap the screen, come on. All right, now it's facing the correct direction. Not really sure what to do here with this touch interface, but you can see that as I move it, it's very glitchy, very jumpy. Let me try lifting it here, because right now it's actually pressed up against this. Okay, see that? Yeah. As soon as I moved it away from the PoE adapter, see how it works way better. So this PoE adapter could be a problem. I could use the Pi 4. I still do have the option of using this Pi 4 PoE hat, which in my experience, these are way less noisy. I found that if you use one of these things, you get perfect results basically. There's none of this glitchiness that you experience here. Actually, you know what? Why don't we try this? All right, let's shut this thing down, and we're going to try with the Pi PoE module. We're going to switch together Pi, and let's get this thing to shut down. Okay, this thing's powering off. What's interesting is if you rotate the screen in desktop mode, the cursor in frame buffer text mode is still in the original orientation. That's kind of interesting. It does give me some ideas though. I could mount it in portrait mode, which could be a nice experience too. But I hadn't thought about that. Okay, so let's get rid of this here. So first of all, this guy comes off. We're going to take this out of the picture. Okay. That is no longer part of it. And I'm very happy I used these mounting posts, because this is very quick to disassemble. Yeah. And we're going to remove this camera, or this DSI interface. Okay. Now we're going to swap in this Pi. I'm just going to move the SD card over. I do know that there are some differences between Pi 4 and Pi 3, but I'm hoping that I get at least a workable system. Oh, hold on. This has some standoffs that I need to remove here, I think. These standoffs are probably from the original case. Okay. All right, so that's in. And this we're going to place exactly the same place as before. Again, I'm just going to use these to push it down. Oh, hold on. This actually could be a problem. If we want to use the PoE hat, the PoE hat lives here. I'll need a long enough screw. This screw here might be too long, or the wrong pitch. Okay. These are the original, I think. These screws held it into the case. These are obviously not long enough. I'm just going to take this hat off. So now we have the PoE hat. Place the PoE hat on. And this isn't as secure as I'd like it, because this hat has its own standoffs, which we're going to have to come up with a solution to make some sort of standoff work in this case. For now, this should be okay. I don't think it'll be a big problem. Okay, so now we're going to power this directly. Okay. Let's see. Okay, so I saw the light come on. Now, is this... Okay, so let's see. The Pi has a light. The screen light... Oh, okay, hold on. Yep, the screen is alive. Okay. Yeah, that's great. We can just move the SD card to a new Pi and it works. I gotta admit, I really do like that about the Raspberry Pi OS. This is booting. Okay. Oh yeah, that's significantly better. Look at that, there's no jumping. Let's configure the screen rotation. Maybe I have this rotated from where I did before, but yeah, look at that, that's perfect. The keyboard should be a lot more usable now. Let's just, yeah, look at that. Oh yeah, I can type. Okay, well, I think that, let's just try, oops. Make sure that we should be able to see the I2C device. And yeah, there we go. Great, okay, well, this seems to be working. I think that's good for this time. This has been a lot of work. I think I've learned quite a bit. So what I'm gonna do is I'm gonna leave this thing updating. So yeah, this is working. And next time we're gonna build the full device. We're gonna put some software on this. I'm not sure what I'm gonna do for a frame, but next time at least we no longer have to worry about all this hardware configuration, which is the big pain in the butt. This thing is finally working and I'm happy with how it's very responsive. The screen is extremely bright. We have to figure out how to get hardware acceleration working for video streams because I'd like to stream those cameras directly. I prefer not to use a browser, but I might not have a choice. Maybe I have to use a browser. We'll have to see what happens. Yeah, we'll put it together and hopefully build like a touchscreen front door controller that will have saved a significant amount of money if you compare this to the UniFi solution, the official UniFi solutions that they sell, which are extremely expensive. So, okay, with that, I'm going to cut this video here. We're going to try next time to build a full system. So again, thanks for watching and we'll play with this some more. Okay, bye for now.